Hello and welcome back. Today in this video we are going to discuss the last few questions from March 2021 Pure Mathematics 1 AS level, that is 970912. Here is the question number 5. In the diagram, the graph of y equals fx is shown with the solid lines. This is y equals fx. The graph shown with the broken lines is transformation of y equals fx. This is the transformation of this curve. Describe fully the two single transformations of y equals fx that have been combined to give the resulting transformation. So what we can see that first of all, this must have been gone from this place to this place, that is transformation of 1, 2, 3 and 4, that is translation. It is horizontal translation of 4, and then we can see this corresponding to this point will get here, another point will get here. So if we talk about the y coordinates here, it is 2, and corresponding to this we'll get it here, and the y coordinate is 6. It means we have multiplied by 3. So we can see the two transformations. First one is translation, so we'll write it. So first one is translation. Translation with, if we write like this, then it is going to give full information. Translation with vector 4 0. 4 0 means 4 horizontally and vertically no translation. So, and the second one is it is called stretch. If we multiply by something in the y coordinate, that is called stretch. So we will write stretch in y direction. And the next thing, which is with scale factor 3. So these are the two transformation being used. We can alternate, we can change their like we can say first it is stretched then translated. That is not a problem. So like we have done it here as a translation first and then stretch. We could have stretched it first and then translated. That would be the same answer. Let's discuss the B part of it. And here's the B part. State in terms of y, f and x the equation of the graph shown with the broken lines. So we have seen from the first part that it is transformations, two transformation, that is first one is translation and second one is the stretch. So we can say that from here fx, if it is translated with 4 0, then it will become f of x minus 4, and then if it is stretched, then it would be scale factor with 3, so 3 times x minus 4. So we can say that y equals fx would be transformed into y equals 3 times f of x minus 4. So y equals 3 f of x minus 4 is the equation of the graph with the broken lines. I hope it is clear. Let's discuss the sixth question now. Here's the sixth question. A curve is such that dy over dx equals 6 over 3x minus 2 whole cube, and a 1 comma minus 3 lies on the curve. A point is moving along the curve and at a the y coordinate of the point is increasing at 3 units per second. A part is to find the rate of increase at a of the x coordinate of the point. So first of all, let's write the informations. So at a, if we talk about at a, the rate of increase of y coordinate, it is dy over dt because it's a rate of increase. So dy over dt is given as 3 unit per second, and dx over dt we need to find, and let's find out what is dy over dx when at a equals at a, that is at 1 comma minus 3, what is dy over dx. So it is going to be 6 over 3 times 1 minus 2 whole cube, that is 6 over 1 cube. 3 1 is 3 minus 2 is 1. 1 cube is 1, so it is going to be 6. So let's calculate dx over dt. By chain rule we can write dx over dt as dx over dy, that is the reciprocal of this, multiplied by dy over dt. So we can rewrite it as 1 upon dy over dx, but that's fine, we can take the reciprocal directly here, and it is going to be, it was dy over dx was 6, so this would be 1 upon 6 multiplied by dy over dt, that is 3, so it is 1 by 2. So rate of increase at a of the x coordinate is 0.5 units per second, or we can say half units per second. So that's it. Let's discuss the b part. And here's the b part. Find the equation of the curve. So the informations from the first part in the question, or we have given as dy over dx as 6 over 3x minus 2 to the power 3, and a point on the curve is given as 1 comma minus 3. So now we know that if we have the derivative of the function given, the equation of the curve, we can directly write it as y equals integration of the derivative, that is 6 over 3x minus 2 whole cube dx. Now why this point is given? So that we can calculate the constant of integration, because whenever we do the integration we get a constant of integration, at least in the not in the definite integral but here. So it is going to be, we can rewrite it as 6 times 3x minus 2 power minus 3 dx. So it is 6 times 3x minus 2 to the power minus 3 plus 1, that is minus 2, so we will divide by minus 2, and we will multiply by the derivative of this. The derivative of this is 3, so we will multiply by 3 here, and plus constant of integration c. So we can calculate, see 2 3 is 6 and 6 cancelled, so we got y as 1 over 3x minus 2 to the power 2, because this is minus, so we will take it in the denominator so that it will become plus, equals plus c. And at a because we know the point A lies on the curve, so at a this is going to be minus 3 equals 1 over 3 1 ja 3 minus, that is 3 minus 2 whole square plus c. It is going to be 1 plus c, or we can say that c is going to be minus 3 minus sorry, it is minus here because it was minus here, so minus 1, so c equals minus 3 plus 1, that is minus 2, and once we got constant of integration we'll substitute here and we'll get the equation of curve as y equals minus 1 upon 3x minus 2 whole square minus 2, and that's the equation of the curve. We could have multiplied and take the rest LCM and we get something like numerator upon denominator, but that's fine because they haven't asked for simplified form. So that's the answer. I hope it is clear. And here's the question number 7. Functions f and g are defined as follows: fx defined as x square plus 2x plus 3 for x less than or equals minus 1, gx defined as 2x plus 1 for x greater than or equals minus 1. A part is express fx in the form of a plus x whole square plus b and state the range of f. So in this type of question means it is given that we need to use this completing square method to express this in the form of this. So it is going to be x square plus 2x plus 3 equals, and using the completing square we only require the x square term with the coefficient as 1 and x term, so we only use these two, and we can use this completing square method by the taking the half of the x coefficient, that is half of 2, that is 1 whole square, and subtract the square of this term. Square of this term will subtract, and square of 1 is 1, so we'll subtract 1, and plus 3 as it is because it was here, so it become x plus 1 whole square plus 3 minus 1 is 2, so plus 2. And we need to express in this form a plus x whole square, so we can always write x plus 1 whole square as 1 plus x whole square plus 2. And here a and b are an integer. It was not mentioned, but it is like an integer. And now we need to state the range of f. For that, first of all, we need to see what is the turning point, and from here the turning point is when we put this bracket equals 0, means x plus 1 equals 0, we will get x equals minus 1. So x coordinates of a turning point is going to be minus 1, and when it is gone, then we are left with 2. So the turning point is minus 1 comma 2. So if we have a graph like that, minus 1 2 would be here, so the graph would be like this, and hence we can see the minimum point is here 2. So the range of f would be fx greater than or equals 2, because here we have minus 1 in the domain, so that's why the range is fx is greater than or equals 2. Now here's the b part. Find an expression for f inverse x. So from the first part we have seen that fx can be written as x plus 1 whole square plus 2. So from here we will first of all write fx as y. In order to find the f inverse x, we'll follow the standard procedure, and the next one is when we interchange x into y and y into x, we'll get x equals y plus 1 whole square plus 2. And now we'll make y as a subject, and at the last we'll replace y as by f inverse x. So from here we can write x minus 2 equals y plus 1 whole square, or from here we can write y plus 1 as plus minus square root of x minus 2. So we got plus minus both. I'll write y equals plus 1 that side, it is minus 1 plus minus square root of x minus 2, and at the last we'll write it as f inverse of x. But we cannot have plus minus both, and for that we can see this is f inverse x, that is a range. This is a range of f inverse. So range of f inverse is same as domain of f, and domain of f was x should be less than or equals to minus 1. So in order to get this value less than minus 1, we have to include minus, not the plus 1. So hence f inverse of x become minus 1 minus square root of x minus 2, and that's how we decide whether to take plus or minus. I hope it is clear. And here's the C part. Solve the equation gf composite function gf of x equals 13. And here's the C part. Solve the equation gf of x equals 13. So first of all, I'll bring the function so that it would be easy. And here's the function now. So if we need to solve this, it means, and we know fx from the first part, we have written fx this as x plus 1 whole square plus 2. So we'll use this composite function. So we can write g of f of x, and fx is this, so I will put fx value as x plus 1 whole square plus 2. Now this is the g of fx, g of this function equals 13. Now we'll use gx, means x, if x is the input for g function g, then the output is twice the input plus 1. So this would be twice the input, and input here is x plus 1 whole square plus 2 and plus 1 because it is plus 1. So twice the input plus 1 equals 13. So we need to solve this. So we will simplify it now. It is twice, I will write it as it is twice. Now we'll expand it, we will get this only. So we should have started with the direct function fx because it is not any way helpful. It is 13 and minus 1, which is 12. I transfer this plus 1 to the other side, and then we can cancel this, and it is 6. So it becomes x square plus 2x plus 3 minus 6 equals 0, or we can say it is going to be x square plus 2x plus minus 3, because it is plus 3 and minus 6, so minus 3 equals 0, and we can factorize it. It is going to be x plus 3 and x minus 1 equals 0, because 3 minus 1 is 2 and 3 into minus 1 is 3 minus 3. So the roots are x equals, from here x plus 3 equals 0 means x equals minus 3, and from here x equals 1. So we have two values of x, but from here we can see for the composite function gf of x, the input should be from the domain of f, and here the domain of f is x less than, x should be less than or equals minus 1, and hence this is not possible. We'll write not valid input, and hence the x equals minus 3, the solution. So this implies x equals minus 3 is the solution of gf of x equals 13. So we have to be careful with the last output. If there are two values, we need to check whether this is valid, which value is valid. I hope it is clear. Let's discuss the next question now. And here is the question number 8. The points A 7,1, B 7,9 and C 1,9 are on the circumference of a circle. A part, find an equation of the circle. If we see the points, we can see in the first 2 points x coordinates are same, and the last 2 points y coordinates are same. It means if we say it, if we look at it carefully, A and B, let's say it is A and it is B, then B is vertically above the A point because the x coordinate is same, and since C is 1,9, so it would be towards the right, towards the left, and now B and C would be on the same horizontal line. So C is going to be here 1,9. So it means this is a horizontal line and this is a vertical line. It means it's a 90 degree, and we know that angle in semicircle is 90 degree. It means AC would be a diameter. So we can write since angle ABC is 90 degree, so it means AC is a diameter. If AC is a diameter, so if we mark O as a center, then center coordinates O would be midpoint of A and C, that is 7 plus 1 divided by 2 and 1 plus 9 divided by 2, or we can say that center is going to be 7 plus 1 8 by 2 4, 9 plus 1 10 by 2 5. So center we have as 4, 5, and if we get the radius, then we'll write the equation of the circle, and the radius is, if it is 4, 5, the radius is the distance between OA. that is radius is OA distance, and we know the distance formula for 2 points, and that is going to be 7 minus 4 whole square plus y, difference of y coordinates and square, 1 minus 5 whole square. It is going to be 7 minus 4 3 square is 9 plus 1 minus 5 minus 4 square is 16. So it is 225, which is 5. And hence the equation, we know the equation is x minus center x coordinate whole square plus y minus y coordinates of the center whole square equals radius square. So it is going to be x minus 4 whole square plus y minus 5 whole square. This is the x coordinate, this is the y coordinate, equals radius square, and radius is 5, so it is 5 square. Or we can rewrite it as x minus 4 whole square plus y minus 5 whole square equals 25, and that's the equation of circle. I hope it is clear. And here's the B part. Find an equation of the tangent to the circle at B. So it means I have copied the diagram from the previous part. We need to find the equation of the tangent at B. So this is a line, we call it as tangent because it touches the circle at B. And if it is tangent, then we know the angle between tangent and the radius at the contact point is 90 degree, and hence OB, we can find the equation of tangent by taking the one point we have as B, but we require the gradient of the line. If we have the gradient of the line, then we can use the formula. So let's find the gradient of the line. So first of all, we will find the gradient of line OB. Gradient of OB line is going to be y coordinates, difference of y coordinates, like y2 minus y1, 9 minus 5 over 7 minus 4, and it is going to be 4 over 3. And hence the gradient of the tangent, I'll write it as m, is going to be negative reciprocal, that is minus 3 by 4. We know for the perpendicular lines, their gradients is, the product of the gradient is 1, so minus 1, so that's why the another gradient would be negative reciprocal. So now we have a gradient. We can write x1 as 7, y1 as 9, and hence the equation of the tangent would be y minus y1 equals gradient, that is minus 3 by 4 times x minus x1, 7. So it will multiply by 4 here, so it is 4y minus 36 equals minus 3x plus 21, because minus plus 3 7 is 21. I'll bring this to this side. Minus 3x become 3x plus 4y minus 36 minus 21 is going to be 7, 3, 2, 5 equals 0. So that's the equation of the tangent to the circle at B. I hope it is clear. We could have written in any of the other form there, but that's fine. So that's it for this video. We'll discuss the last 3 questions in the next video. Till then, thank you so much.